podcast. Hello and welcome to Build Reversion Lab at DevX Belgium 2024. And first interview of the conference, very excited to be here. We have tons of content. I think we're like 30 interviews or something like that, so stay tuned. There will be a lot. My first guest, hello and welcome, Andrea Peruffo.
Nice to be here. Thanks for having me.
My pleasure. And look how we have the design build Reversion Lab DevOps right here. Oh, I like it. It looks great. Andrea, so welcome to the show.
Thank you.
And you mentioned that your talk was about WebAssembly.
Yes.
WebAssembly, it's kind of a big deal those days. Maybe not as AI, but close enough.
Yeah.
Everybody are talking about it. And it looks like it's yet another attempt to do what Java promised to do, and then Docker promised to do.
Yes.
Right. So that's like it's all this cross-platform unit that you build once and run anywhere.
Correct.
So how WebAssembly is different? Why? This is the answer to our prayers of cross-platform compatibility.
Yeah, so we have had it in Java with applets and with many other technologies, as you mentioned. But with WebAssembly, the security is built in. So you run in a sandbox, and your memory is fully controlled. And you have to give explicit access to system resources to your WebAssembly module. So it becomes extremely easy to build, to embed it in your application natively without having security concerns and security risk that killed many other technologies. If you want to compare it instead to container, that's interesting as well, because a container is like shipping your entire machine. You have to start your application, have a million of packages or operating systems that are booting up, etc. Instead, WASM will run straight ahead in your application as a process. I like to compare it with a system process that is running in your machine that enable you much quicker boot time and much more security and stability, as I mentioned.
So, as the name implies, WebAssembly is that the idea, at least in the beginning, was that this is a common low-level language for things to be run in the web.
A common binary format that can be ported for the web. And it was firstly designed because they wanted to port a gazillion of lines of C++ code into JavaScript applications to be able to run, for example, graphic design and those kind of things. You're using WebAssembly for sure when every time you're using Google Maps, Excel, or whatever application behind the scenes.
So okay, so this is the idea was, how do we write web applications in languages that are better than JavaScript?
Yes.
Basically, right? This is what we want to say. Now, but Java is mostly living on the server side.
Correct.
So what it has to do with WebAssembly?
But, well, it's amazing as well, because you really want to extend your application with different programming languages. And if you go, for example, in the cloud-native runtimes, everyone is writing Go applications, and you want to be compatible and give the opportunity to people to have plugin systems and customize your Java applications running on the server using any technology they come from. So they can write plugins written in Rust, Zig, C, Go, JavaScript even, and run them on the server side, customizing your monolith application on the server.
That sounds good. You also mentioned a build which is simpler than what we used to have with other languages and more reliable.
Well, WebAssembly is a standard, so all the compilers are targeting it as a different compilation target. So you can. There are a ton of compiler engineers which are putting effort into making sure that their languages are compatible and executable in WebAssembly runtimes. And, well, we can take advantage of it.
That makes sense. So how does it work? How do I start if I'm a Java developer?
Yes.
Right, and I want to use WebAssembly for example, maybe writing a plugin for some application that is not written in Java, but it's compiled to this lowest common denominator of WebAssembly. What do I do? Where do I start?
Well, if you can compile your application to WASM, and then what I'm building is a project called Chicory, which is a WebAssembly runtime in pure Java. So it is built straight on top of a standard library with no external dependencies, and it runs on any JVM starting from 11. And basically, you just have to load the module provided, compiled to WebAssembly that was written in Go to your application, load it, and execute some function that it will be exporting. So when you're writing the guest code that will be compiled to WebAssembly, you are exporting functions for exposing the functionality to your host. And the Java application can invoke this functionality on the WASM module that is provided by the user.
It sounds a lot like GNI.
It does, but it has immense benefits out of it, because at this point we are running just pure Java bytecode inside the JVM. We are not escaping the boundaries of the JVM, so the memory is confined and limited and is completely defined within the JVM boundaries. You are not accessing external libraries that, if they crash, will crash your JVM. Everything is running just with the same monitoring, observability, and all the great features of Java applications, just as normal Java bytecode.
That sounds good. So again, what is the name of the project?
Chicory.
Chicory. All right. So folks, check out Chicory. Check out Chicory. Ah, that sounds fun. It sounds like this technology is something that should definitely be on your radar. WebAssembly in general, the port in Java. Andrea, thank you very much for joining. It was very interesting. We learned a lot. And you all folks, stay tuned for more episodes of the Build Reversion Lab from Devox Belgium 2024 coming up right up to you. Thank you. Bye-bye.
Thank you.